Great, thank you. Hello, everyone. Good morning, good afternoon, wherever you are. This is Jonathan George. I'm the Product Marketing Manager at F5. We're going to talk to you today about DNSSEC. Is your infrastructure ready? There's a lot of reasons to secure your DNS, and we're going to review today the different ways you can do that, as well as just review some timing and some industry response that we've seen. At the end, towards the end of the presentation, we have a time of question and answer, and we actually have a panel. We have Cricket Liu, the VP of Architecture from Infoblox, an industry leader and visionary in DNS management and server management space. We also have Peter Silva, the Technical Marketing Manager here at F5. He's our evangelist for security. So we really think this is going to be a valuable time for you to, if you don't already know about DNSSEC, to come up to speed and find out all the opportunities there for protecting your DNS responses. First of all, we just want to run through, why would you want to protect DNS? What are the challenges and benefits that you may see or the industry sees in supporting DNS security? We're going to talk about who implements. If you don't implement DNSSEC, what are the consequences or what are seen in the marketplaces as issues? How to protect your DNS, and then when. There are a number of different time frames that we've seen over the time that is a good time to start protecting. And then, of course, what are the solutions related to DNSSEC in relation to F5 as well as Infoblox? So why protect DNS? Well, we've seen a lot of different companies as well as industries dealing with DNS attacks, hijacks, or cache poisoning of the DNS responses, many different high-profile, in the news DNS attacks, whether it's a government, whether it's actual financial institution, whether it's social media. A lot of these companies and organizations and industry verticals will take and provide queries and provide responses, but a lot of times those aren't necessarily secure and could be taken for granted until a hijack happens, a DNS attack actually happens. So we actually went out to the marketplace and did a survey, and a couple of responses that we received were into our inquiry, what are the challenges or obstacles in supporting DNSSEC? Well, DNS security, for some, can be complex for implementing. Maybe there's just not enough information about the benefits in the marketplace. Some may know about the benefits, but they're waiting for a top-tier domain to be signed, and we'll talk about that in the following slides, what that is, if you don't know. And then maybe even a lack of demand from users. Another thing we found out was the benefits, again, weren't necessarily completely defined. And in asking the marketplace about how important certain benefits were, we really received back that, the one thing, if they did know about DNS attacks, they wanted to be able to protect end users from falling victim to theft or fraud because of redirection. Really, the next thing was if their DNS responses are being rerouted, is there confidence in the integrity of the information of your brand? Obviously, if there's DNS attacks that are happening, you may not know about it. That's potentially an issue with the brand where individuals would find out that their information is redirected somewhere else, and so if they did find that out, they might be less likely to go back. So that's a brand issue. And then, of course, dealing with the fact that your organization plays a key role in fostering a safe community. Now, we have a couple of slides on just really an analyst review of a survey that was done about who's actually going to implement DNSSEC once it becomes available, and there are solutions available. For those that know about DNSSEC and they understand the attacks and cache poisoning, really, once they know about it, many and most will implement to protect against the type of DNS attacks that they see in the marketplace. Now, who is really as you can see there in the bottom right, a number of different verticals and industries that feel it's very valuable to provide secure DNS responses back to clients, whether it's online commerce companies, internet service providers, finance, the public sector being the government sector. Many different industries we see are truly interested in making sure that the information they're sending back is getting received by the end client. Now, what's the cost of not implementing DNSSEC? Well, it can be very, very expensive. Down the right-hand side, you see the many different types of DNS-based attacks that we see in the marketplace. And, of course, the costs are varied here. The highest amount that we see is in the multi-millions of dollars. So it can be very expensive for hackers to obtain financial information, data, customer data, and be able to use that against a client or consumer, as well as that information not being received back by the originator. So how to protect DNS? Well, here's the actual Wikipedia response of what a domain name system security extension is, which is DNSSEC, but really it's just a set of extensions to DNS which provides the DNS client origin authentication of DNS data. So a user then is requesting information from a site, and it goes to that site. Then DNS servers will respond, as well as a DNSSEC solution, and actually provide a secure DNS response so that the actual client receives that trusted response, and hackers that are trying to attack and provide cache poisoning, other types of attacks in the LDNS along the way, they're not able to. And so then we see that in the marketplace, DNSSEC has become more and more important as different zones have been signed. Over the last 6 months, we've seen .com, .gov, .net, .edu, many different zones being signed. I mentioned .com because up till now there's about 30,000 zones that have been signed. 30,000 sites that have been signed because of all the different zones. But now we see that over the number of years that various different extensions being signed, we have .com that's being signed the end of March of this year. So now we're going from about 30,000 potentially up to 100 million of availability to receive DNSSEC. You can see here that it's been happening over a period, a number of years. Not only was there specifications for DNS security that were finalized, really Dan Kaminsky, the gentleman that found the cache poisoning vulnerability, which we're going to explain here in a couple of slides, since then it has increased dramatically. In the 2009 timeframe, the U.S. government required that all .gov sites were DNSSEC compliant, so there was a compliancy focus there, especially for the federal government, but as well, many state governments started to take those requirements on. We saw various different zones, such as, extensions, whether .org, .edu, .net, being signed. We feel that, and we see in the marketplace that not only government, but universities and various different nonprofit organizations are starting to look at more and more ways to secure their DNS. We think that it will continue now with .com at the end of next month. And rightly so. We want to provide protected responses to those clients that are requesting information. In the traditional DNS, it is insecure as, for instance, if you're requesting information from a site, that request may go through one or a number of different servers before it gets to the final location. DNS servers will then respond with information with a DNS server response going back to the user, again going back through an LDNS server, at least one, if not a number of them, before it gets to the final client. Now, to do that every time, of course, could take quite a bit longer, what happens is a lot of times that recursive name server has cached the response, and then future requests are then, that cached response is just then sent back to the client. What happens when a hacker comes in and requests that information from the site, then they'll drop in the cache poisoning an attack where it's redirecting, providing an incorrect DNS response, and then redirecting that response back to, say, the hacker, as opposed to that information from the client going back to the site. Again, this loss of valuable revenue and customer data. This is rogue servers now being poisoned with DNS, the DNS cache being poisoned. Again, we talked about brand integrity declining, and then really now organizations, especially .com coming up here, need a method for trusted responses. Now with F5 as well as Infoblox, you can enable secure and dynamic DNS. So now a hacker tries to place cache poisoning in the local DNS, and they're unable to because the responses, the DNS query responses coming back from the site are managed by a Big IP Global Traffic Manager with a DNS security feature. It actually dynamically signs the response and protects that response going all the way back to the user. Now, that information is cached in the LDNS so that on future requests to a site that does have DNSSEC in place, that protected response is in the local DNS, and so that protected response is sent back to the client, and many times as opposed to having cache poisoning. This ensures users get trusted DNS queries with signed responses. It's quite a simple implementation in that a lot of you already have DNS servers, or you might be looking at new DNS servers. With Big IP Global Traffic Management, it's an easy feature add-on service for DNSSEC. And then it helps you keep revenue avenues open and customer data protected.
So, hey, Jonathan, real quick. So the threat to the end user, you know, if there is DNS cache poisoning, is that they go to a rogue site thinking that it's their financial institution or somewhere like that, and they enter their sensitive information, and now the bad guy has that information. Because certificates and signatures and those verifiers are involved with DNSSEC, it then, you know, authenticates the response and verifies that they are going to the actual site requested rather than the rogue site or the hacked site.
Great, thanks, Peter. That was Peter Silver, our Technical Marketing Manager.
Woohoo.
Now, Big IP Global Traffic Manager not only provides a very simplified DNS security feature, but also provides optimized application delivery, enabling global traffic to be sent to various different multiple data centers based on business logic. Maybe one site's down, and so it needs to redirect traffic to other available sites. Geolocation services, users coming from different locations being sent to their local site for support, or it could be just automatic failover during outages. And then with Big IP Global Traffic Manager, it's easy to support via IP geolocation, where users are coming from various different locations around the world. Global Traffic Manager can send them to the recent site. And then for DNSSEC, you know, the same DNS request might result in 3 different dynamic responses depending on the client. If you're looking at potentially a DNSSEC solution that's using pre-signed records, this is not possible with a standard DNSSEC solution. You really need dynamically signed responses. This is easily configurable with F5 Global Traffic Management solution in that all you need to do is 3 different steps. Create a key signing key, create a zone signing key, and then create that DNSSEC zone. Now, after you send the public key signing key onto a parent zone authority. In the future, you just need to repeat the first 3 steps to sign additional DNSSEC zones. Now, F5 has a very strong relationship with Infoblox. They provide superior DNS management. We know that probably a lot of you have heard of Infoblox and maybe have Infoblox implemented in your organization. With both of our solutions together, we provide high-performance DNS scalability and easily and dynamically can provide DNSSEC signing for all zones. In fact, Cricket Liu, who's on the phone today for our panel, as well as may provide color commentary, has provided a quote here that both of our solutions together really provide an opportunity to build authoritative DNS infrastructure while continuing to add DNSSEC and global server load balancing. Infoblox really makes it easy for DNSSEC. On the Infoblox side, we can easily go into an Infoblox DNS server management GUI and easily configure DNSSEC parameters. Any zone can be signed with a single click. We can enable DNSSEC a single click very easily. We enable the trusted anchor configuration. Maintenance of signed zones is very easy. There's automatic notification. New zone signing keys are automatically generated. We feel it's very valuable to combine both solutions together for authoritative DNS security and infrastructure. So again, with F5 and Infoblox together, we see in the marketplace that DNS hijacks are growing. DNSSEC delivers origin authentication of DNS data. Many different verticals and industries are starting to implement DNS security for a number of different reasons relating to brand protection, but also large potential losses are happening when DNS hijacks are in place. And then, again, DNSSEC protecting your DNS responses and brand. We see the .com zone is going to be signed coming at the end of March of 2011, and we feel that enabling both F5 Global Traffic Manager with DNS security as well as Infoblox DNS Server Management provides an easy implementation for dynamic DNS, secure DNS, and superior DNS management. Now I'm going to turn it over to our panel, and we're going to take questions. We've got Cricket Liu, again, the VP of Architecture at Infoblox, Peter Silva, who you heard just a minute ago, the Technical Marketing Manager here at F5. We're going to take live questions that you may have regarding DNS Server Management as well as DNSSEC.
Thank you. If you would like to ask a question, please press *1. Please record your name so I may introduce you. To withdraw, you may press *2. And again, to ask a question, please press *1.
So while the questions are coming in, this is Peter. Jonathan, if you could go move back just 2 slides, or maybe. So, hey, Cricket. So what's the importance really of automatically generating keys and key rollover and that? Why is that significant and important with DNSSEC?
That's a really good question. You know, originally when we first began supporting DNSSEC with bind name servers, it was a really clumsy, cumbersome process to sign a zone. In the 4th edition of DNS and Bind, which was the first place I covered it, I think it was a 12-step process. It was all done with command line tools. If you wanted to sign any zone, it was a 12-step process. You can quit smoking as quickly, right? So, you know, our focus with DNSSEC has been automating everything possible because we really believe, and I think you guys at F5 believe too, that the only way that DNSSEC is going to be successful is if it's nearly automatic, if it doesn't add a whole lot to the administrative burden of somebody who's responsible for DNS. So we wanted to make signing just a matter of, you know, clicking the Sign Zone button in the graphical user interface. Because we know how to sign a zone. We know that you have to generate, you know, 2 key pairs, a key signing key and a zone signing key, and that you need to add all of these signature records to the zone and so on. We know, for example, that when you want to roll over your zone signing key, there's an algorithmic way to do that. We can do that automatically. So I think that's really been the focus for us at Infoblox, that automation of the management of sign zones.
Cool. Thank you.
I do now have a question from Ian Strong. Your line is open.
Yes, hi. I guess a couple of questions. So to implement this, do you need the Infoblox solution, or can you do it totally using the 3DNS?
This is Cricket. I mean, I didn't want to jump in for the F5 guys, but yeah, I mean, you can do it totally with GTM. You know, if you have non-Infoblox name servers even as your authoritative name servers on the backside, you can implement DNSSEC signing on the GTMs. Basically, what they do is they intercept the queries as they come in, they pass the queries through to the authoritative name servers. They see that the responses need signing, and then they'll add the signature records.
It was a previous slide, but it basically said something to the effect that you generate the keys and then you load them to some higher level or some authority type server. What is that? Would that be the GTM?
Yeah, I don't think there's any loading. Peter can probably answer better than I don't think you have to load them on the authoritative name server. All that really happens is that the GTM notices that the query that came in has a bit set called DNSSEC OK. It passes the query through, it gets the response from the authoritative name server, and then it adds the signature information, which is generated using the keys.
Yep.
Okay. Thank you.
Thanks, Rick. Appreciate that.
Sure.
And as a reminder, if you would like to ask a question, please press *1.
So while other people are thinking of questions that potentially may be coming in, so, you know, there may be some that are listening to this presentation and saying, you know, that's interesting. Now that we're finding more information about DNSSEC, maybe that's something that we need to look into. But what if they're really kind of questioning in their mind, you know, we don't really see a whole lot of hijacks that are happening with our business that we know of. We're not really losing any revenue from cache poisoning. You know, and I hear that there are potentially other DNSSEC security vendors that manually sign DNS responses. Why would I want to go with F5 and Infoblox versus maybe a manually signed DNS security vendor? And I guess I'll start out with Peter, and Cricket, if you want to chime in.
Yeah. So one of the reasons is simply if you're trying to do global server load balancing. So, you know, load balancing various data centers, taking geolocation information from the user, and then determining from that piece of contextual information where to send them. And what's challenging is, you know, usually you'd have to manually enter all the potential or possible combinations of locations, or, you know, IP addresses, or all the different answers that possibly could come out from this DNS request. And so that can be very challenging in the olden days. I tend to say that a lot, in the olden days, which is only like 10, 15 years ago. You know, most of this was just, you know, static, and so, you know, it was only to this location. But with global server load balancing, the answer could change depending upon where the user is requesting from, and that can be very challenging to ensure that all the possible combinations are there. And so that's why, or one of the reasons why our solution is actually very easy to implement, is that the global traffic manager makes the determination on the fly as to where is the best location to send this request, and then signs that on the way back to ensure that the user is going to a valid site.
Yeah, I think Peter's right. I mean, the really novel thing that F5 has done with the GTM implementation of DNSSEC is to make it possible to, you know, globally load balance DNSSEC signed responses. That's a pretty hard thing to do because, as Peter points out, you know, you've got all these different permutations and combinations of responses that you might send back. And the thing to keep in mind is that every different combination has a different signature. And pre-computing that is generally not possible. The GTMs have the oomph to actually sign on the fly and generate the correct signature, even though they don't know ahead of time necessarily what combination they're going to return. From Infoblox's standpoint, we have what we think is a very good graphical user interface for managing signed zones. So if you're just dealing not with global server load balancing, but with just your standard authoritative zone data and you want to sign it, you need to administer it over time, we think that we have a very good intuitive way of managing that. And we have this underlying infrastructure called the grid, which is a single point management solution that gives you all kinds of resiliency and disaster recovery built in. So that's our sort of pitch to you about implementing DNSSEC.
I do have a few questions on the phone line now, if you're ready. You have Matthew Broxson. Your line is open. Matthew, your line is open.
Sorry, I was on mute. I have a question for F5. You mentioned the GTM product, but we also use just the link controller product, which is a bit of a limited version of the GTM. Is the same functionality just for DNSSEC exist there?
Yeah, unfortunately, the DNSSEC feature set is only available on the Global Traffic Manager currently. I don't know, Jonathan, do you have any additional information pertaining to the link controller?
Yeah, as far as we have available today, DNSSEC, it's an add-on module feature module available with Global Traffic Manager.
Okay, thanks.
But that's actually a good suggestion. I'll write that down and send that back to product management. Maybe something to look at in the future.
Would you think it's valuable to provide DNSSEC with just link controller, in your opinion?
Well, in our environment, we do delegate records out to the link controller just for load balancing between two local data centers.
Okay.
So, we're serving up DNS records there, so I would say yes.
Okay. Like Peter said, we'll provide that information back to product management to see if there's potentially a change in the future. But for right now, you have to go with Global Traffic Manager.
Okay, thanks.
Mm-hmm.
Thank you. Next we have Saeed Azinfar. Your line is open.
Yeah, the question is, do we have any sort of documentation on the F5 side as far as best practice for DNSSEC implementation, also a step-by-step configuration?
Yes, this is Jonathan. I can actually answer the first part of that. I'll let Peter just chime in if he wants to. In the very next slide, you're going to see a whole slew of resources, including implementation. In the F5 DNSSEC solution site, we have a solution site on f5.com. There's a direct link there, or if you just go to f5.com, solutions drop down, you'll see security. In there, you'll find a DNSSEC site of a whole cadre of different information, whether it's deployment, whether it's white papers. We've got media as well. We actually have a much more in-depth presentation, I think about 45 minutes, that's available both on F5 and Infoblox. It was a recorded presentation that Cricket was on, as well as our product manager, Nathan Meyer, last year, really going into much more detail on the implementation and providing different designs and configuration designs, diagrams. So if you want even more in-depth information, you wouldn't mind hearing a more technical presentation, there's one available. As well, as you'll see in the resources section, there's various different blogs and forums that we provide links to. And by the way, we'll send this information out after the presentation and provide to you so that you can click on each one and find out more information. As well as on the Infoblox side, there are a number of different links. Both Cricket Liu has his own blog on DNS. He, again, is the forerunner and visionary for DNS. And as well as Infoblox has their own DNS security center. So we have a lot of different deployment information provided for you here.
And I've also on our YouTube channel, which is F5 Networks Inc. off of YouTube. There's actually what I've I do these little series called In 5 Minutes or Less, and so there's a In 5 Minutes or Less video showing the DNSSEC implementation and how to deploy it on a GTM.
Great, thanks a lot.
Sure.
And as a reminder, if you would like to ask a question, please press star 1. It'll be just a moment for our next question.
So while we're waiting for our next question, I wanted to ask Cricket a question. You know, since he was talking before about DNS server management and how easy it is to configure DNSSEC, I thought let's find out some more information. Obviously, Infoblox provides high-quality DNS server management in relation to DNSSEC, but provide us some more information, Cricket, on DNS server management from Infoblox from a solution standpoint.
Well, the cool thing about the grid, which is sort of our proprietary, you know, our secret sauce, if you will, you know, the piece of technology that underlies all of our appliances, is that you can have a network of, you know, a huge number of name servers and DHCP servers and so on, you know, hundreds, 200 appliances out there in the field on your corporate network. You can manage them all from one place. You can manage them all from just one of the appliances that's designated as what we call the grid master. You can upgrade them all from that one place. You can back them all up. You don't have to touch them individually. If, you know, Kaminsky number 2 hits, then you can roll out a patched version of your name server to all those boxes in no time with very little overall effort. And then you get these wonderful resiliency features too. If you have a device fail in the field, we certainly don't like to have that happen, but if one does fail in the field, you can simply replace it with another device. The grid actually has stored all of the configuration and data of that device, so even though the device itself may be down, you can recover it just by plugging in a replacement device, giving it the failed device's IP address, netmask, default route, and secret to join the grid, and it'll reconstitute that failed device.
Great, thanks, Cricket.
Sure.
We do have a question on the phone line from Jim Donaldson. Your line is open.
Cricket may have just answered my question, but I was wondering if the team of you could give me a 10,000-foot view of an implementation that looked like using the Infoblox grid as the primary authority source while delegating subdomains to global traffic managers for topology-based global traffic management.
Yeah, we've actually got a white paper. It's sort of a white paper, sort of a solution note that covers 3 different ways to do that. But it's pretty straightforward. Really, you could have, for example, Infoblox appliances acting as your authoritative name servers, serving, say, foo.example or whatever, and then you can have your GTMs front-ending those boxes and signing responses as they're returned from the Infoblox boxes. Or an alternative to that is to have the GTMs serve a subdomain that contains all of the domain names that you want to have load balanced. So, for example, they might serve some, you know, GTM or GSLB.foo.example subzone, and then the Infoblox boxes would just delegate that subdomain to the GTMs. And then the GTMs, of course, would be authoritative for that entire subzone. Either one of those models works well. I guess the benefit of the first one is that is where the GTMs are effectively screening Infoblox boxes as authoritative name servers, is that you can do all of your zone data management on the Infoblox boxes through our graphical user interface.
This is Jonathan. We did actually have a slide on that, and so I've just provided it up there for you to view. But it's a number of different ways to be able to implement F5 and Infoblox, whether it's authoritative screening, authoritative slave, or delegation.
Oh, great, yeah. And the 2 that I talked about, delegation is over there in the lower left. Authoritative screening, which is the first one I mentioned, is up there in the upper right. And authoritative slave is just a kind of a middle ground where we serve as the master server for the zone data, and we transfer it to instances of Bind or of your DNS Express product running on GTM.
I'm sorry, Peter, to interrupt you?
Oh, no, I was just going to go back to so we did this survey just recently. I think it was slide 4 and 5?
Yeah, I think so.
As I click through your build.
Sorry, animation.
That's okay. So, Cricket, you guys also did a survey back in October. Now, yours was a little more technically focused, talking about key sizes and key lengths and, deployment scenarios and so forth. But does this survey was done in January. Does it kind of jive, with what you guys were seeing in October from your survey, or was there anything that jumps out at you, from, slides 4 and 5?
Well, what I see here on slide 4, I think this reflects what I've seen, actually speaking to audiences and visiting our customers, that people are worried about the complexity of implementing DNSSEC. The survey that we did, the DNS survey we did in the fall with the Measurement Factory, doesn't really point directly at reasons. It's done basically by querying large communities of name servers out on the internet and looking very carefully at their responses to determine how they're configured, whether they have DNSSEC turned on, that sort of thing. We have seen, as we saw from that graph of the number of signed zones determined by the UCLA SecSpider project, we have seen a pretty dramatic rise in the number of signed zones out there, although under ComNet and org, it's still a very small percentage of the overall population of zones.
Right. One of the things I found interesting, actually, is on, slide 5, the top reason or the top benefit that companies noted for deploying DNSSEC was to help mitigate the risk of their end users, and brand came second, which is kind of heartwarming, right? That companies are, more looking out for their end users necessarily than they are the brand, for one, being good internet citizens. But also then kind of interesting, number 4 of the biggest challenges is while number 1 of the benefits is protecting users, lack of demand from users is also, an obstacle and a challenge. And would you kind of like equate that just to the fact that, most end users, most of the normal day-to-day internet users, Ken's mom, for instance, are pretty much unaware of this technology?
Oh, absolutely. We shouldn't expect end users to demand DNSSEC. Right. All but the most informed end users have no idea that DNSSEC is, even a possibility. But they certainly assume that you as, the provider of services over the internet have their best interests at heart. And I think it's just a matter of time before, some online merchant who didn't go to the trouble to sign their internet-facing zones has a customer suffer a loss. A customer is redirected to a hacker site, reveals their login and password and credit card information. All of that stuff is reused. And that disgruntled customer goes looking for somebody with deep pockets to pursue, and the merchant who didn't care enough to sign those external-facing zones is the first place they're going to go.
And, speaking of, merchants and payment systems and so forth, I remember a blog entry from, it might have been last month or the month before, where you had been speaking to a colleague out east, and there was some mention, and I'm not trying to put words in your mouth or anything, Cricket, but that there's some consideration or mention that potentially DNSSEC might be part of the PCI requirements at some stage in the future, possibly?
Yeah, well, that's what I heard from a guy who attended one of my roundtables in Chicago last year, and he was on one of the PCI working groups and said that they're looking very carefully at the possibility of requiring that merchants who accept payment cards also sign all external-facing zones that are involved in any way with online commerce in order to achieve PCI compliance. So that would certainly be a big change, wouldn't it?
Yeah, and personally, I think that'd be, pretty cool, really securing it end to end, from the moment the end user types in the domain name.
Yeah, exactly. I mean, there is sort of a weak link in the chain now. I mean, everybody assumes that, you know, SSL or TLS is going to save their bacon, but, you know, if you actually end up going to the wrong site in the first place, then there's no TLS involved.
Yep.
Great, thanks, Cricket. Thanks, Peter. Operator, are there any other questions?
Yes, I do have a question from Fred Regan. Your line is open.
Yes, hi guys, how you doing? I kind of missed the first couple minutes of the presentation, so this might have been answered. But to implement DNS security, we already have F5 and we already use GTM. We do not use Infoblox. We have our own DNS servers. So my question to you is, overall implementation, am I to understand that it basically is just adding the plugin to the GTMN box and basically making it so it's signing the DNS reply, and once it does that, it goes to the recursive server and to the end user? Or is there kind of like implementation on like provider levels and recursive servers that has to happen before this is end to end?
No, you just...
Oh, go ahead. I was just going to say that, yes, that's a really good point. The administrator of the recursive name server that's communicating with your authoritative name servers also has to do something. They have to configure validation. You know, if the recursive name server isn't actually configured to do DNSSEC validation, well, you can sign your zones all day long, but, you know, it's not going to do anything with the signatures. At this point, now that the root zone is signed, though, configuring validation is very, very easy. It's really just a matter of plugging in a single public key for the root zone and then flipping a couple of bits in the named.conf file, you know, DNSSEC-enable and DNSSEC-validate, I think, or something like that. They both get turned from no to yes. Okay. So it's pretty easy to do. More people are doing it, but it does have to happen in order for somebody to actually check your signatures.
Right.
Gotcha.
And that's really the key, is that chain of trust, you know, all the way up, you know, to root, to top-level domain, to down to your, you know, own name server itself. So there is that. That's what really, you know, kind of makes this all work, is that chain of trust from top level all the way down to the server itself.
Right. Okay. So yeah, like you said, then, so I can turn around and implement this tomorrow. But if all the way up the chain, if they're not, you know, supporting DNSSEC, then there is still a possibility of a hole that it can be interrupted at some point.
But once .com is signed, then, you know, pretty much that should be taken care of.
Right. Okay. Right. So that's true too. Okay. Okay. Thank you very much.
Sure.
Thank you. Next we have Jim Ritchie. Your line is open.
Yeah, hi, this is for F5. I read somewhere that F5 now has a GTM cloud service. Can you comment on that, and if that cloud service includes the DNSSEC functionality?
You want to take that, Jonathan?
Sure. You're saying a GTM cloud service?
Yes, that's what I read.
Okay. So let's see. There is not at this time the availability for a GTM cloud, and maybe let's step back a minute. Do you have a virtualized environment, and are you thinking about potentially having global server load balancing in a virtualized environment before we step into the cloud discussion?
Yeah, well, we have GTM deployed right now, load balancing between two different cities. So
and then do you have virtualized deployments? Some type of virtualization solution?
No, not at the moment.
Okay. Well, so from our end, you know, we're looking at all the different possibilities for the future of supporting virtualization. We don't have a GTM virtual edition at this point, but in the future, we're looking at all possibilities. Of course, then the next step would be then what type of offering could we provide for cloud environments. So,
well, I mean, you know, the GTM can load balance to your cloud environment, obviously, because
sure.
I mean, if you know, a cloud is still servers in a data center somewhere, so it can still do that. And depending upon the cloud provider, if you're able to, you know, potentially insert your own equipment there, then I mean that's, you know, obviously a possibility. But yeah, we haven't you know, released, you know, a virtual edition of GTM at this moment. If that's what you're looking for, you know, code on a virtualized server.
Well, my understanding was that you would be providing a service where customers could, purchase GTM functionality from your cloud and go out and configure it to pull their own web servers and provide that global load balancing.
There may, we're certainly the infrastructure of choice for many of the cloud providers out there, and there are a number of them that do offer F5 solutions through their own, cloud service. So that might be, if you could send myself or Jonathan, an email, we can dig a little further into that if you like, or send us the link to the story or the blog entry or the press release, and we can at least, look at exactly what you're referring to and then give you a solid answer.
Okay, thanks.
Thank you. Next, I have Don Vance. Your line is open. Don Vance, your line is open.
Oh, yeah. I just have a quick question. We were talking about the chain of a trust, and then the root zone is signed. But I'm just wondering, at the user end, is that the last leg covered for DNS for the DNSSEC implementation?
And by the last leg, do you mean between the user's stub resolver and the recursive name server?
Right, between the user and the stub resolver to his resolving server.
Yeah, that's a really good question. I actually wrote a blog post on that. It's sort of the last mile problem in DNSSEC. There are lots of ways to do that. None of them are really commonly used. You could, for example, use TSIG to secure the queries and responses between the stub resolver and the recursive name server. There are parts of DNSSEC that are designed to do that, something called SIG0. You can also use, IPsec. But most of those are not commonly used, so in those cases, the stub resolver is just sort of trusting its recursive name server. Now, in a case like mine, for example, where the laptop that's sitting in front of me is using a recursive name server that's here at Infoblox, provided by Infoblox, that's probably not that big a deal. But for a home user using an ISP-provided recursive name server, that's more of a leap of faith, I'd say.
Right. Yeah. Yeah. Thanks, Richard. Yeah.
At this time, I'm showing no further questions.
Great. Okay. Well, this ends our portion of the Q&A with both Cricket and Peter, and we thank you very much for your responses and for everyone's questions. Again, on 21, as we showed before, we have a whole list of different resources from F5, as well as some links to very interesting articles, and as well as Infoblox DNS Security Center and Cricket's blog. So we'll send this out to you as a follow-up so that you can review all the different information, as well as deployment, as one gentleman was looking for. And then finally, for F5, we can connect anytime. You can connect anytime for more information on various different social media sites. As Peter mentioned, we have our own F5 network sync on YouTube with lots of different videos up there, including information about DNSSEC.
And then how do people follow you, Cricket, and Infoblox?
Well, at Infoblox, I've got the cricketondns.com blog, and also on Twitter, I'm Cricket on DNS.
Great. And again, from F5 and Infoblox, we thank you very much for listening, and absolutely consider F5 Global Traffic Management with DNSSEC, as well as consider Infoblox DNS Server Management. Thank you much, everyone, and have a great day.
Thank you.
Thank you. That concludes today's conference. You may disconnect at this time.